Now let's consider this question. Now a kettle rated 2000 watts contains water at 20 degrees Celsius. The kettle is switched on and after 2 minutes the water starts boiling. Now after another 6 minutes, 45% of the water in the kettle boils away. Now determine the specific latent heat of the vaporization of water. Alright, now first of all, let us look at this question in this way. Now we have two cases here. Now before the boiling and after the boiling. Now, and we are not given the mass of the water. Now what we need to do here now, let us first of all calculate the mass of the water before boiling. Okay, now and let's take note that the general principle concerning heat energy is the heat gain by a system equals to the heat loss by another system, or vice versa, that the heat lost by a system is equals to the heat gain by another system. So which implies here that the electric energy delivered by the kettle, given as IVT, then equals to the heat MC change in theta, the quantity of heat absorbed by the water. Okay, now where I is the current, V is the volt, T is the time, and mass, M here is the mass, C here is the specific heat capacity of the water, and change in theta is the change in temperature. Okay, now to this end, and we are told that the power rating of the kettle is 2000 watts, and IV here implies the power rating. So here we have 2000 then times, now the time here before it starts boiling is 2 minutes, and that will be 2 times 60. We are multiplying by 60 because we need to convert to seconds, then equals the mass here is what we are looking for. Now, and the specific heat capacity of water is 4200. Now the temperature change here before the boiling of water, that will be 100 minus 20. Okay, all right, and the reason is before it boils, water need to get to 100 degree centigrade. So, and that is why I'm making use of 100 here. So here we have 2000 times 2 times 60 here, you should give us 120, then equals mass, then times 4200 times 80. Now let's divide both sides by the coefficient of m here, which is 4200 times 80 and 4200 times 80. The whole of this eliminates, so m, then let us see, 0 cancel 0, 0 cancel 0, 0 cancel 0. Okay, we're left with 20 times 12 all over 42 times 8. Okay, we can still divide further. 6 here, 2, 6 here, 7. 4 here, 2, 4 here, 5. 2 here, 2. So our mass is now 5 all over 7 kilogram. Okay, all right, now that we have our mass as 5 all over 7 kilogram, now let us now consider the second scenario. After boiling 6 minutes, now 45% of the water in the kettle boils away. Now boiling away implies vaporize. Okay, all right, and at this point of vaporization, the water has a constant temperature of m. Okay, all right, so to this end we will also relate the energy the kettle, the electrical energy the kettle generates, which is the heat loss. Then okay, so here, sorry, in this case we have the latent heat. So here we have that IVT equals ml. Now the reason why we're having latent heat here, because there is no change in temperature. Now because at this point the temperature of the water, the boiling water, is just 100 even as the vaporization continues. Okay, so to this end, let's take note that the rating also is still 2000. Now but at this point the time here, after 6 minutes, so 45% of the water in the kettle boils away. So here we have 6 times 60 then equals to the mass. Now take note here, 45% of the mass. So 45% of 5 all over 7 kilogram. Okay, yeah, that's how it is. So then here we have 45% of 5 all over 7 times L. Okay, so the whole of this, so here we have 2000 times 360, yeah, then equals, let us quickly solve this here. This is 45 all over 100 times 5 all over 7. Okay, now 5 here 1, 5 here is 20, 5 here 4, then 5 here 9. Okay, is there another thing? So we end up having 9 all over 28. Okay, so to this end we now have 9 all over 28 L. Okay, so for us to find the value of L here, let us multiply both sides by the reciprocal of 9 all over 28, and that should be 28 all over 9 times 2000 times 360 equals 28 all over 9 times 9 all over 28 L. And this is to help us eliminate the coefficient of L. So at the end of the day, L will then be, now finding, multiplying all through here, we have 201,600,000, okay, then all over 9. So the latent heat here will then be 2.24 times 10 raised to the power of 6 joules per kilogram. Alright, this is the final answer. And if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos. Thank you and God bless you.